Hello everyone, this is going to be my sort of in-depth overview about my computer and kind of what it does and how it works. So this video is going to be mostly unscripted, hopefully not too many cuts and stuff, so I'm just going to be kind of going through all of the parts. So this right here is the control center, kind of where all the displays and inputs feed into and out from. So while we're going through it, I'll start a program. So let's restart it to make sure everything is cleared out. Alright, so now we can see the process is finished and we heard that tone, so it's ready to go. So while we're looking at everything, I'm just going to do the count by one program. So this is just going to store 0 in the RAM, and then as it goes, it's just going to keep counting one by one and displaying it. So we can just get that one down, put in input mode so that we can begin the execution, and we don't need any inputs. So if I do begin execution, we're good, the program is on, and we can start the clock. So now the program is actually running, and as it goes through, we can see what clock cycle the CPU is on, and we can see what instruction line this is going to be reading from. So this program, I believe, is only one line, so it's never going to leave from 16, and we'll see this go up and up and up. So let's see here, we're on clock cycle 7, so now it's going to go back to 0, and we'll see that rather than going on to the next line, it's going to stay on 16. And now we have one on the display. So the first thing we should look at probably is the ROM. So the ROM is sort of like the hard drive, and this is where all of the instructions for how the programs work are held. So if we look at line 16, which is where we're at now, we can see this lamp is on so that it's working, and these torches are on. So this is the instruction line. This has all of the instructions for how to run the program, and it all exists on this one line. So basically what this part here is the go-to address. So it says when this line is done executing, where do I go? And if you have any booleans, booleans are the conditions that we set onto the CPU. So for instance, if a number is 0, if a number is negative, or if the number is too big, we can set things like that, or even the opposite of those values. So this one says that if all of the booleans that are set are true, then go to line 16, which is here. And all of this is in binary. This one saves the value of 1 to the third RAM address here. So that is so that we can continually keep adding 1 to the address. And then this one loads the value in RAM 4 and into the first register. So the first register is the first number that the operation will be happening to on the CPU. And then it will load the third RAM address, which, as you remember, we loaded 1 into it. So it's going to do the fourth address and then the operation here on the third. And so this is the subtract key. So if it's on, it will be in subtract mode, and if it's off, it'll be in addition mode. So it's going to do the fourth value plus the third value, which is 1. And then this is the save. So after it completes this operation, it's going to save it back into the fourth one and then display it. Or these are the booleans. So we have no boolean set, so no matter what, it's going to be true over there. And then this is the display. So it's going to send the fourth RAM to the first display. And the first display is the big display that you see that has all of the numbers on it here. There are only two other displays. There's the remainder display and then the error display. So depending on what you set for the display address is where that value will go. And so if there is nothing here, if this torch isn't on, then it will just go on to the next address. So if I took this torch out, it would go onto line 17 after it finished executing. So the program counter is what I was talking about with the go-to lines. So this pretty much just says if this isn't being called, then go on to the next line that is there. And then if this is being called, it allows the value that is being put from the program into this address here. So this just keeps track of where to go. So this is all binary, and then these are the decoders, these gold and diamond lines. So every single line has its own unique address, which is signified by a number in binary. So these figure out if that number is the address number, and then only turns on that lamp, which you see here on 16, because 16 is the one that's coming through the wire. So when you actually start the program, the way it gets to that address in the first place is through the directory. So that's what these things are here. So when I started count by 1, when I flip this, see here, it's below us. So this just goes right the way over here. And because it's currently running, the directory actually will not activate all the way over here. But what we'll see here is the count would be right here. So when the execution starts, this just holds the value for the ROM address for which all of the programs start. So you can see that for count, it is line 16, which is right here. And this just goes along the same line that we saw the goto addresses. So essentially what the begin execution button does is it just resets the clock. So resetting the clock would put it to the address where it's supposed to go to, and it would put the cycle to 0. So once that finishes, the program is ready to begin at the beginning of the line, and it will be set to the proper line, so 16 in this case. So once the line, it's on the proper line, then everything goes through to here, which is pretty much the processor. It's a little jumbled up, but everything is handled by this little machine here. So this is the clock. So everything is controlled by this for the timing. So as you'll see, it progresses by this way. And so depending at which stage this is on, the line over here will fire, which pertains to each function on the line. So first, at 0, it's just set to getting everything handled with all the torches getting over here and the redstone signals. Then it forces the value to the RAM if you need to. So this is an 8-bit value, and then this is the RAM address it would be going to. And if it doesn't have any of this, it will just not do anything there. Then it loads the RAM address that you select into the first register, and then after that it will load the second value. Then after that it takes a break to just finalize the calculations, because that can take a little bit, because the calculator section called the ALU in the CPU is kind of complicated, which is over here. So because there's so many torches, it takes a while to catch up with 16 bits. And then after that little rest period, it saves the value to the RAM that you select. Then there is some period to check for the booleans. And then once all of that updates, it is ready to send the display. And then after things are set to the display, it goes on to the next line that it's supposed to go, either by going on to the next line or by going to the specified value if the booleans are activated. And as I mentioned before, if there are no booleans, then it will automatically be assumed to be true. So if I didn't have a way to end programs, then it would just run forever and go through all the lines. So what I've done is, for the 0th address of the ROM, there are 64 addresses, so 0 to 63. So this is the final address. And all it does, the only thing it has set up to do, is go back to itself. So the only command on here is go to line 0. And so this is where you are able to do all the inputs, do all of the go-tos and the directories. So line 0 is reserved for all of those functions. And also when you are on line 0, that's when the process finished comes on. So whenever the thing is finished, whatever program you're running, it will always go back to line 0 and it will let you know over here. So as you can see, this program has been running for a while, and we are already on 19. Now 20, so that's 16 plus 4. So this line has executed 20 times since we started running it. So this here is how it connects to the RAM, these pink lines. there are 7 RAM addresses. The 0 address is just a clear line, so it will either save to nothing or bring nothing into the register. So that's a way of kind of erasing during, like in the middle of executing a program. So the usable addresses start from address 1 and go all the way to 8. This design for the RAM is admittedly terrible, and I should have changed it before finalizing the project, but I couldn't think of a better design. So by the time I work on the next one, I'll have something much better. So as we can see executing here, this is the 3rd value, and remember every time it saves 1 to this value. Then the 4th address is the value that it is currently going to be displaying in this current program. So we can see here that that is the current value that's going to be displayed over there. So all of these values from the RAM, when they're called, go into the registers here. So up here is register 1 and down here is register 2. And basically all these are is where the values get saved so that they can be mutated by the ALU without interfering how they are actually saved in the program. So the second value, in order for subtraction to work, is actually very interesting. It uses a method called 2's complement, which is handled by these blue lines here. So essentially all this does is it inverts what is coming off of the second register. So if one of the lines is on, it will turn it off, and then if it's off, it'll turn it on. And then it sends a value into the carry. So essentially that is equivalent to adding 1. So it does 1 plus the inverse, or the value in the first register, plus the inverse of the value in the second register, plus 1. Then that is equivalent to subtraction. And so that only happens when the negative part in the ROM is called during that instruction line. So this is where all of the math actually happens here. This is the ALU. And all of those values get sent up over these lines. This is where the force value comes in. So every time for this program, we send the value 1 into the 3rd RAM. So that's where this happens. But all of the values that come out of the ALU go over this line, which is accessible by all of the RAM addresses. So when you actually go to save that value, it's saved into whatever RAM you call. So even though this is running over all of them, it will only go into the one that you specify, which is the same for how it reads. All of the RAMs will see that there is a call to be read, but only the one that matches the address will actually be read and output. Also, I should bring up the booleans too, kind of the circuitry for that. So this here is the checks if it's 0. So if all of these are off, then this will be on, which means that the value is 0 coming out of the RAM. This is the overflow. So this pretty much signifies if the value is too big, but if it's in subtract mode, this signifies if the number is negative. And actually it will be on if it's negative, and it will be off, or oh, I'm sorry, it will be on if it's not negative, and it will be off if it is negative. So we have to do some inversion with that. And so because kind of how that works, a number can't be too big while also negative. So you can't do those simultaneously. But what you can do is a not, which is here. So for instance, if I wanted to say if it is not 0, so that would be, if it's not 0, if I wanted anything greater than 0. So what that would do is it would invert the value coming out of here, which is the result of all of the booleans. So this checks here for the ones coming out of the program compared to the ones that are coming out of the ALU, and then says, okay, well, are these true or are these false? Then it goes through here, and then this either inverts it or keeps it the same based on the not operator. So that's pretty much how all of the reading and writing works. The only thing left that is huge is how the displaying works, which is all done through these brown lines here and through the pink lines again, because it is another form of reading. So when the display happens, first it pulls the values down if there are any. So those values will go over these gray lines. So these gray lines feed into the big display. And then the brown lines are the address for the display in which it wants to go. So if you remember, the first value is to display to the big screen. So let's see here. So yeah, the big screen is here. Then the second value, I believe, is the remainder. And then the value 7 is the error display. 7 or 3, I don't remember right off the top of my head, but it'll be in the documentation or the video about how to make a demo program, which I will be making pretty soon. So you'll see that all there. Then it all ties together into this little section here. So there's some feedback, so every time it goes back to address 0, it plays the chime you heard when it finished restarting. This controls the clock that you saw over there, which controls the cycle, and then the clock controls the instruction line. So now that we've looked at all the hardware, I think it would be pretty cool to show you guys how using all this can actually make a functional program. So I put this little slide together to show how those simple instructions that you can do on the computer can make complex programs. So forgive my atrocious handwriting, but as you can see here under the in-ROM, so this is actually what I programmed in the computer. So it takes up lines 4 through 7, and all that does is input 1 times input 2. So translating what's in ROM into English, we get the little bullet points on the bottom. So first on line 4, it checks if the second input is 0, then display 0 and end. So that's where you see line 4, load RAM 2, and then if RAM 2 is 0, go to line 7. And what line 7 says is to load what's in RAM 4, save it to RAM 8, and display RAM 8. So since nothing is in RAM 4, then it will display 0 and end, which is the red dot at the end. So if it isn't 0, then that means it will go on to line 5. So what line 5 does is it loads the 4th RAM, so the first execution it will be set to 0, and then it loads RAM 1, which is the first input, and then adds them, and then saves it to RAM 4. So then it goes on to the next instruction, which is on line 6, then it checks the second input minus 1, and then saves that to the second RAM. So if that is not 0, then it will go back to line 5. So you'll notice that it will keep going back and forth until the second RAM value is 0. So that's where we get add input 1 to itself for input 2 times. So once that is finished, it will be allowed to go on to line 7, which is where it will load RAM 4, which is the value of at this point it is the value of the multiplication, save it to RAM 8, and then display RAM 8 and finish. So as you can see, just by simple addition and subtraction, you're able to do multiplication. And from multiplication, think about all the things you can do. And as a demo program, I've even included square roots. So it's really crazy just how these crazy little simple things can do really cool things if you scale it up. So I hope this makes sense, and hopefully you can think of something cool to create yourself with it. Well, thank you for watching. I hope you learned something new from this. I'm hopefully going to start working on a new project soon. I want to make it with a actual graphic display. So I actually have pixels that I can manipulate and draw lines and maybe even build like a GPU in Minecraft. I think that would be really cool to work on next. But if you had any questions about this, need any help or clarifications about how anything works, please don't be afraid to reach out. Again, I hope you enjoyed. Have a good day.